Good morning everyone. My name is Nikam Shweta and today I will be giving presentation on parallel computing and distributed databases. So basically what is the distributed database? In distributed database, we are not saving our whole data on one system, that is we place the data in multiple systems. The benefits of it is that while processing that data, the query time is required very less and thus we can process a large amount of data in small time. So basically, why distributed database? Why should we use it? As we know, the data which we are saving is a huge in amount. So if we save it on one system, it will take large time to process it and thus making our system slow. By taking an example, we can say that if one bank is having many branches, the each branch data is being saved on a different system, so that while processing the data of one person, it is being processed on that branch only. The other examples are chain of retail store with many locations, library with many branches, etc. So basically, what is the benefit of distributed and parallel processing? That is fast response time for queries, which in turn makes our system very fast and effective. So now we will see what are parallel databases. Machines are physically close to each other. Example, that is same server mode. Machine connects with high dedicated speed LANs and switches. Communications cost is assumed to be small in parallel databases. That is been the various type of parallel databases, that is that different architectures are shared memory, shared disk, share nothing architecture. So basically, why parallel processing? As we can see in this example, the first example depicts non-parallelism, in which one task can be displayed one time, and in the other, all the tasks are being displayed at the same time. As we can see, the time required to complete the whole task is in first pick 1.2 days, and in second, that is 1.5 minutes. That is, by using parallelism, we can reduce the time of implementation, and thus we can do lot of work in small time. So the different architecture in parallel processing are basically there are three: shared memory, shared disk, and shared nothing. We are going to see all the three one by one. So first is shared memory architecture. In shared memory architecture, every processor has its own disk. Single memory address pair for all processors. Reading and writing to far memory can be slightly more expensive. In this type of architecture, every processor can have its own local memory and cache as well. The pic shows the architecture of shared memory, that every processor has its own disk and all. Next is shared disk architecture. In this, every processor has its own memory, that is, the memories which is not accessible by others, it is private to itself. All machines can access all disks in the system. Number of disks does not necessarily match to the number of processors, as the figure shows the shared memory architecture. The third one is shared nothing architecture. This is the most commonly used architecture nowadays. Every machine has its own memory and its own disk. Many cheap machines, that is commodity hardware, are being used to make this architecture. Communication in this type of architecture is done through high-speed networks and switches. So now we'll see what are the types of parallelism. First one is pipeline parallelism, that is inter-operator parallelism. In this type, different tasks are being run on different machines in parallelism. That is, ordered tasks and different machines are performing different tasks. The example, the picture here shows pipeline parallelism. And the next one is partition parallelism, that is intra-operator parallelism, in which we can see that one task is being divided into subtasks and those subtasks has been processed on different machine. So that is partition parallelism. So that's it. Thank you.